Welcome back. All right, now we are going to solve inequalities today with fractions and decimals. So this first one here, this is in your 5.7 notes here. 5.7 notes. If you scroll down, we're down here where it says practice and solve and graph. Solve and graph. So if we're trying to solve for n, the inverse of negative 2.8 is adding 2.8 to both sides. So be very careful here. Negative 4.5 plus 2.8, Pierre, you said that's going to be negative, right? So what I'm going to do, I'm going to take 4.5. I'm going to subtract from that 2.8. Now this is going to be what, Pierre? Positive or negative? 4.5 minus 2.8, that's going to be positive, right? So whatever this difference is, I'm going to take that difference, I'm going to change the sign. If you're wondering why I do that, think about 9 minus 7 as compared to 7 minus 9. They're exactly the same, except for this one is positive 2 and this one is negative 2. So when you think about 7 minus 9, you're probably thinking, okay, that's just like 9 minus 7, except for the difference is negative. So that's the same idea here. 5 minus 8, can't easily do that, so we're going to borrow here. So 3, and that becomes a 15. 15 minus 8 is 7. 3 minus 2 is 1. Bring that down that decimal, we get 1.7, positive 1.7. Slide back over here, and we get n is greater than, now what does it need to be, y'all? Negative 1.7. So there we go. There is our inequality. Now, negative 1.7. Who can tell me what two numbers this is between? Quinn. What two integers, I should say. Sorry.
Negative.
No, that's not an integer. You're close.
Oh.
Negative 1 and negative 2. All right, it's important that you realize what two integers you're between. Now, Quinn, negative 1.7, is that a bit closer to negative 1 or a bit closer to negative 2? Negative 2. So let's put an open circle a bit closer to negative 2. And let's also label this as negative 1.7. So that way everybody knows where we're at. Okay, are we going to shade this to the left or to the right? To the right. Okay, so n is on the left side of the inequality. That's good. If your variable's on the left side of the inequality, if it's greater than, you will shade to the right, like we're doing right now. If the variable is not on the left side of the inequality, you would need to shift that around so that it is. All right. With all that in mind, everybody take a moment and write the interval notation for this. Write the interval notation for this graph. Okay, well, if we go to the right forever, on the right side of our comma we have infinity, and infinity always gets a parentheses. So the low end is negative 1.7. When I say the low end, I mean like our blue graph in this case doesn't go any lower than negative 1.7. Yes, the number line does, but this blue shading does not. Open circle or closed circle? I'm sorry, parenthesis or bracket? Parentheses. There you go. There's your interval notation. Questions on that? Okay. So with all that in mind, if you're at home, pause the video now. If you're in class, try this one on your own. B minus 5/6 is greater than 3 2/3. Pause the video now and try that one out. So if we take a look at this problem, the inverse of subtracting 5/6 is adding 5/6. So we add 5/6 to both sides. It looks like that. We need to find a common denominator between 3 and 6. What is that common denominator? It is 6. So I'm going to go ahead and change 2/3. 2, we got to multiply by 2 in both of these, right? So we end up with 3 and 4/6. Questions about what happened there? Okay, so now we're looking at 3 and 4/6 plus 5/6. 3 plus nothing is 3, right? So we got 3. 4 plus 5 is 9. We keep that denominator 6. So we got 3 and 9/6. Now we got something kind of weird going on. We've got a mixed number and an improper fraction inside of the mixed number. We don't like that. So Carson, 3 and 9/6 is the same thing as what? Yeah, 4.5, right? There's a whole, like how many groups of 6 are there in 9? There's 1, right? So 1 plus 3 is 4. We'd be left with 3 over 6, which is 1/2. So 4 and 1/2. 4 and 3/6 is 4 1/2. So there we go. We're done with that. I would encourage you to find your answer in the form of a mixed number rather than an improper fraction. Here's why. 4 1/2 is between what two integers? Flynn, what do you think? Not Flynn. Finley.
4 and 5.
4 and 5. So we have 4 here. We got 5 here. So is it closer to the 4, closer to the 5, or right in the middle? Right in the middle. So let's put 4 1/2 here, right in the middle. Open or closed circle, Chloe, what do you think? Open circle. Shade left or right, Claire?
Right.
Right. And let's write the interval notation here. So Jack, comma. If we go to the right forever, where do I put the infinity? On the right side of the comma. Does it get a bracket or a parenthesis? Parenthesis. And then on the left side, we write 4 1/2. Does that get a bracket or a parenthesis? Parenthesis. So there we go. There's our answer. James. 4 and 3/6. Yeah, I need you to simplify your fractions anytime. Like your final answer needs to have all the fractions simplified. All right, we skipped over the two above this, so let's scroll back up. Here's two problems. I want you to work those two out on your own. One of them has a fraction in it, one of them has a decimal in it. Good luck on those two. You may want to work off to the side if there's like if the space is a little tight here. All right, so let's take a couple minutes to try that. If you're at home, please pause the video, try those two problems out. I didn't record, sorry. So we're going to subtract 3/8 from both sides. Now, the common denominator of 1, which is that denominator there of the 2, 1 and 8, the common denominator is 8. So we slide over here. 2 becomes 16/8, right? 16 divided by 8 is 2. So 16/8 minus 3/8, we get 13/8. 13/8. We're going to rewrite this so that it's a mixed number. That's 1 and 5/8, right? There's one group of 8 and 13. We're left with 5. So a is greater than or equal to 1 and 5/8. So let's go back to the number line here. We're going to be between 1 and 2. Is 1 and 5/8 a bit closer to 1 or a bit closer to 2? 2, right? So let's put a mark there. 1 and, what did I say, 5/8? 1 and 5/8. Open or a closed circle? Closed circle. So again, it was a is greater than or equal to 1 and 5/8. We shade left or right? Greater than, we shade to the right. Comma, if we go to the right forever, on the right side of the comma, we have an infinity symbol. It always gets a parenthesis. On the left side of the comma, we have 1 and 5/8. What does it get? A bracket because of the closed circle. This shows you that 1 and 5/8 is included in the solution set. Carson, you had a question? You still get 1 and 5/8?
Yeah.
I'm okay with it. Yeah, they're not always this simple, right? So the ones that are more complex, you will have to do what I did, but this one's simple enough. You can probably just look at 2 minus 3/8 and know that's 1 and 5/8.
Well, no, that's not.
Okay?
Pretty much what I did.
All right, let's take a look at the second problem. We're trying to solve for r. The inverse of positive 14.92 is we're subtracting 14.92. So we subtract that from both sides. Let me slide to the right here. Oh, by the way, I should add, is this going to be positive or negative when we subtract 14.92? It's negative, right? So what I'm going to do is I'm going to flip it around. We talked about this earlier, but I'm going to flip it around so I get a positive difference. So that's positive 14.92 minus 7.65, giving us 7.27. This is exactly the opposite of what we want, so we're going to change the sign to negative. So r is greater than or equal to negative 7.27. r is greater than or equal to negative 7.27. So negative 7.27 is between what two integers? Griffin, what do you think? Very good. Negative 7, negative 8. Is it a bit closer to negative 7 or a bit closer to negative 8? Yeah, so we're going to put a closed circle here, a bit closer to negative 7. Let's write negative 7.27 so everybody knows where we're at. And Connolly, do I shade left or right? To the right, right? Greater than, we shade to the right, so long as the variable's on the left side. Let's write the interval notation. If we go to the right forever, on the right side we have infinity. It gets a parenthesis like always. On the left side we get negative 7.27. Because that closed circle, what do we have to do? It gets a bracket. So it's that. Okay? Let's talk about word problems and some words we might use to describe these symbols. So this is the greater than symbol. What's a word we can use like in life outside the math classroom that means the same thing as greater than? Elise? More than, right? What else? How about increased? Or something like that. Maybe not. Nah, increase kind of means addition, right? We'll go more than. We'll go greater than as well. Okay? Or any synonym for those two. Okay? This symbol means less than. Yes, Pierre. Yeah, fewer than. Or any other way you can phrase that to mean less than. Okay? Oh, we're missing the symbols here. Put the line underneath that and put the line underneath that, so we got greater than or equal to, less than or equal to. So greater than, let me zoom in here. This is greater than or equal to. What's another way to say that, Christian? At least. At least. Piero?
No less than.
No less than? Yep, that'd be good too. No less than. What else? That's good for now. How about minimum? Minimum. And the last one here, that's less than or equal to. Less than. Piero? At most. Elise?
No more than.
No more than. Good. And then, yeah.
Do you say at greatest?
I'll probably say maximum. Go with maximum. Okay. There's a few different ways that these symbols can show up using language, but these are just a few of them. So there you go. Make sure you get those down, and you can reference these as needed. So you will use these to solve word problems. So let's see here. We've actually only got a minute left in class. So we're not going to take the time to do this, but here's some examples you could try. You would need to define a variable, write an inequality, and solve. Your homework tonight is going to be on this practice master sheet. I'm going to send this to you. It's only 4 problems. That's it. Make sure you share your work off to the side. Thanks so much for watching. Hope you have a great weekend. I'll see you back here on Tuesday. Oh, hey, I should add, everybody listen up carefully. This is our last section. So we're going to have our test review on Tuesday. We'll have our test on Wednesday. Test on Wednesday in this class, y'all. All right, thanks for watching. Have a great day.